I welcome you all, and you are watching the most expected questions for GATE exam, and this is the fifth video of thermodynamics. And in this video, I have taken some questions on the concept of entropy change calculation and irreversibility. If you want to calculate the change in entropy and if you want to calculate irreversibility, the small concept involved for that is he will ask you, there will be the cases he will give you in which you have to find out entropy change, and the cases he will give you, there are a couple of cases here. So there are these cases which actually you will find the question to calculate entropy change. First case will be ideal gases. He will give you the ideal gas and ask you to calculate entropy change when the gas changes its state. So there are three formulas for change in entropy for ideal gases. These are S2 minus S1 is equal to MCP log of T2 by T1 minus MR log of P2 by P1. So let me tell you what are these formula. S2 minus S1 is MCP log of T2 by T1, that is for ideal gases we are calculating, minus MR log of P2 by P1. So that is the first formula. Second formula which we can calculate for ideal gas change is MCV log of T2 by T1 plus MR log of V2 by V1. And third formula is between V and P, MCP log of V2 by V1, MCP log of V2 by V1 plus MCP log of V2 by V1 plus MCV log of P2 by P1. You see these three formulas. These are the formulas of entropy change from state 1 to state 2 for ideal gas. So T1 T2, P1 P2, V1 V2. He might give you any of these things. So this formula is between T and P, this is T and V, this is V and P. You need to memorize these three formulas. So MCP log of T2 by T1 minus MR log of P2 by V1. All of you must have memorized it. Sometime he writes P1 by P2 and instead of negative he writes positive. So just remember what is given, and when V2 by V1 it is Cp, when P2 by P1 it is Cv. So you need to think it of. Normally these two formulas you get in the books, but this formula is not available in the books, so you remember it. And then there is a third formula which is for polytropic process. If PV raised to power n is equal to constant is given for ideal gas, then TDS is equal to dq, which is equal to mc dt. You understand this way? So ds is equal to mcn dt over t. You understand? So mcn log of t2 by t1. So S2 minus S1 for any polytropic process is calculated like this. So that is another formula for ideal gas you can think of. So for ideal gases, what can be different kind of formulas between temperature and pressure, temperature and volume, volume and pressure. And another formula, if polytropic index n is given, so use Cn, and Cn can be calculated if we know the value of Cv. Cn is equal to Cv, that is specific heat at constant volume, n minus gamma over n minus 1. So you can use this particular formula also. So that formula can also be used. Something like this, you can use this formula for ideal gases. Remember these formulas. Another domain from where entropy change can be calculated is if the reservoir is given. Reservoir के case में entropy change is nothing but Q by T. Reservoir is something which has constant temperature, right? Its temperature does not change. Even if there is a flow of heat, its temperature does not change. And hence either the entropy will increase or decrease. If heat flows, that is out of the reservoir, that is the source, then entropy of the source decreases. If there is a sink, like ambience, heat flows to the sink, so entropy will increase. So how much is the heat flow and what temperature this reservoir is, depending upon that you can calculate entropy increase or entropy decrease. That is a reservoir. Third can be for free expansion process. Free expansion is the process which is having constant internal energy. Fourth is the throttling process. So process can be throttling process. This can be the another case. Throttling is the isenthalpic process. So normally he will ask you to calculate entropy change either for this ideal gases, and you have these formulas, or reservoirs in which you are to use this formula Q by T, or throttling process, isenthalpic process or free expansion internal energy constant process. So these are couple of cases from where he will ask you to calculate entropy change, and this entire thing, these 10 questions are based upon that only. And then there is a term called irreversibility. You know, irreversibility is nothing but irreversibility is T naught, that is ambient temperature, into delta S of universe. And you know what is delta S of universe? Is delta S of system plus delta S of surrounding. And if the system is adiabatic system, then only you need to calculate delta S of adiabatic system, because adiabatic system is universe only. So that is how you have to calculate the irreversibility, you know. And delta S universe is nothing but ds generation, also entropy generated, which we have discussed in the previous video of thermodynamics. So these all questions are based upon that. So all you have to do is give yourself 15 to 20 minutes and solve these 10 questions, and if 7 are correct, 0 incorrect, that is a good performance. So let us start now. I go for first question. Read this question carefully. Air at 20 degrees centigrade and 1.05 bar occupies 0.025 meter cube of volume. Now the air is heated at constant volume until the pressure becomes 4.5 bar. It is then cooled at constant pressure back to original temperature. Calculate the net entropy change. Up to 2 decimal you have to calculate in joule per Kelvin. So that is what we have to calculate now. Let's see whether you can plot the PV and TS diagram for this. You know, always you should feel comfortable to draw PV and TS diagram. So air was earlier 20 degrees centigrade. Can you tell me how isothermal process is plotted? This is the constant temperature process plotted on PV diagram, right? T is equal to constant process. Now let us say air was at particular temperature 20 degrees centigrade. This is 20 degrees centigrade and 1.05 bar. Let us say this is 1.05 bar, and its volume is given as 0.025 meter cube. Now you heat it at constant volume until pressure becomes 4.5 bar. So let's heat it at constant volume and its pressure becomes 4.05 bar, 4.5 bar, sorry. So that is the pressure now it has become. Then it is cooled at constant pressure. You know, cooling at constant pressure will be, so 1 to 2, let us say, and 2 to 3. So 1 to 2, 2 to 3, till its temperature becomes again 20 degrees centigrade. So PV diagram will be something like this. Okay, the moment I draw TS diagram for this, TS diagram, you know, constant volume process 1 to 2, this is constant volume process, and this is constant pressure process. So 1 to 2, 2 to 3, this is constant volume, this is constant pressure, and T1 is equal to T3. So I'm sure you got the concept. So how you have to draw the process which is given in the question on PV diagram and TS diagram. This is how you can draw these diagrams. Now, as I told you, this is the ideal gas, and he has given you T1, he has given you P1, he has given you V1, and then he has given you P2, and V2 is same as V1 for first process. So ideal gas P1 V1 by T1 is equal to P2 V2 by T2. V1 is equal to V2, so we can find out what is P2. T1 T2 is T2 we can find out. P1 P2 are given, so we can find out what is T2. Now T1 T2 are known to us, P1 V1 everything is known to us, so I can use the formula which I told you. Ideal gas का formula हम लगा सकते हैं. So air के लिए we know what is Cp, we know what is Cv, we know actually Cp 1.005 kilojoule per kg Kelvin, and Cv is 0.718 kilojoule per kg, and R is nothing but Cp minus Cv, that is 0.217 if I'm not wrong, and gamma, which is Cp by Cv, that is equal to 1.4. You need to memorize these kind of values. So just remember, I think this is what Cp minus Cv you have to calculate exactly what is this value coming, 287. So these values we can use and we can find it out. Second case mein obviously we know T3 is equal to T1 and P3 is equal to P2. So we know P and T. Any of the formulas can be calculated and answer can be seen what is the value. The most important thing is whether you got the answer correct or not. So temperature is, you have to convert it into Kelvin, 293 Kelvin. V1 is equal to V2, P1, P2 are given to us. So from this we get what is the temperature T2 in Kelvin. Mass can be calculated, PV is equal to MRT. So for air, R is 0.287 kilojoule per kg Kelvin. So we get that. Normally these values are given. We can calculate what is S1 minus S2. We can calculate using this formula. I told you there are three formulas: MCP log of T2 by T1, MCP log of T2 by T1 minus plus MR log of V2 by V1, or MCV. So we have couple of formulas here for as I told you, this S2 minus S1 is MCP log of T2 by T1, MCP log of T2 by T1 minus MR log of P2 by P1, or you can use MCV log of T2 by T1, MCV log of T2 by T1 plus MR log of V2 by V1. So in the first case 1 to 2, V1 and V2 are equal, so only formula will be this. So from 1 to 2 what you get is, for 1 to 2, MCV log of T2 by T1. So T1 T2 we have calculated, MCV, this value of CV we can calculate, and we can calculate it. And 2 to 3 we can use the formula 2 to 3, because pressure is same, we can use this formula MCP log of T2 by T1. So that formula we can think of using, and because T2 T3 by T2 will come, T3 temperature is same as T1 and T2 is known to us. So if we use these formulas we get these two values there, and if we add, then in one case entropy is going to increase, another case entropy is going to decrease. So in the heating case entropy will increase, and in cooling case entropy is going to decrease, right? Okay, let's go for next question now. Calculate the change in entropy of 1 kg of air which expands in piston cylinder mechanism from 10 bar 500 degree centigrade to 1 bar by following the process jiska index of expansion is given to us. Now you know, whenever some question comes to the whenever some question you come across in the exam, always think of writing what is given. Just think of what is given. So mass is given 1 kg, right? And pressure P1 is given 10 bar, and temperature T1 is given 500 degree centigrade, and P2 is given as 1 bar, and process is PV raised to power 1.2 is equal to constant, that is given to us. Now we know dq is equal to mc and dt, right? Dq is equal to, that is equal to TDS, dq is equal to TDS, and that is equal to mc dt. So we want to find out ds, that is mcn dt by t, and if I want to integrate it, what I get is S2 minus S1 is mcn log of T2 by T1, log of T2 by T1. Now this is the question which is given to us, and in this case Cn in terms of Cv can be calculated. Now air is given, we already know what is Cv, and if n is given, gamma is also known to us, I can calculate what is the value of Cn. Now in this case it is given that there is a piston cylinder mechanism, expansion is there 10 bar 500 centigrade and 1 bar. This process is already given to us. So using this process, you know, I can write PV raised to power n is equal to constant, and you know, this very process for ideal gas, I can always write PV is equal to MRT. Ideal gas equation I can write. So if I put ideal gas equation into this formula, I get these two more formula, TV n minus 1 is equal to constant, T raised to n over P raised to power n minus 1 is equal to constant. These three formulas always you remember. PV raised to power n is equal to constant, T into V raised to power n minus 1 is equal to constant, T raised to power n over P raised to power n minus 1 is equal to constant. These three formulas come from here only. That means in this formula PV raised to power n, if P I write in terms of T, P is nothing but MRT over V. If I write like this, MR is constant, so I need to write T over V. So T, P की जगह अगर मैं लिख देता हूँ T over V, तो T V raised to power n minus 1 बन जाएगा. So something like that. Now in this case, P1 T1 is given to us, right? And P2 is also given to us. So if I know P1 T1 P2, T2 can be calculated, and if I know T2, I can put that value here, and Cn will be known to me as I explained you. So see what is the solution given to us. There may be some mistakes here, don't bother about that, just you calculate. Printing mistakes, calculation, printing calculation, that problem can be there, but this is the formula, you know. S2 minus S1 is equal to, this is Cn log of T2 by T1, and because mass is 1 kg, so you can take m as 1. Understand? So how to find out now T2? As I told you, this is a formula. T raised to power n over P raised to power n minus 1 is equal to constant. So T2 will be obtained. This is CV. This is now n minus gamma over n minus 1. So n minus gamma over n minus 1. Just see what is the value coming. And when you put this in the formula, you should get the right answer. If you see most of the times, 60 to 70% gate exam mein 60 to 70% concepts are repeated every year. So only thing you need to practice is calculation part. You should not make any mistake in calculation. Paper is actually not difficult. Paper is easy. So 10 to 20% paper may be difficult, but you cannot say entire paper is difficult. It is only 10 to 20%. 60-70% paper is easy. Only thing is आपको calculation में mistake नहीं करना है. Okay, let us see. This question is a good question now. So he has given you what? He has given you the values of specific heat, values of constant pressures, constant volume. Cp, Cv are given as basically variable terms of temperature. So Cp is A plus Pt and Cv is B plus Pt. A, B, P are constant. So don't think this P is a pressure. I think this P is constant only. T is the temperature. So Cp and Cv are function of temperature. As the temperature increases, Cp also increases, Cv also increases, right? Because Cv increases more, isliye gamma decreases. So remember this always. With increase in temperature, Cp also increases, Cv also increases, but Cv increases more, so gamma decreases. That is a concept you should keep in your mind. Let me write it here. As the temperature increases, sir, Cp increases, Cv increases more, gamma, which is Cp over Cv, decreases. Remember this term always, right? Okay, now he has given you this particular thing, and now he says which one is the correct expression of S2 minus S1. So all we need to do is little integration and analysis. What is dq? Dq is equal to TdS, that is the second law, and TdS as per our first law is du plus pdv. So let's write dq is equal to, du can always be written as cvdt plus pdv. Then what I do, I write ds is equal to cvdt. This is the general expression from where if I integrate, then I get S2 minus S1 is equal to Cv log of T2 by T1 plus R log of V2 by V1, because P over T ko I can write it as P over T as R over V. So this is the same thing which we have done, and I gave you the formulas earlier, the same thing. But you know what? In this case now, Cv I will write as, and R I will write as Cp minus Cv. So R is Cp minus Cv, which comes out to be constant. So A minus B करके बाहर आ जाएगा, A minus B log of V2 minus V1 आ जाएगा. But Cv is a term which is a function of temperature. So what is Cv? Cv is B plus Pt. So when I integrate B plus Pt, I get this B log of T2 by T1 plus P log of now T2 minus T1. That is this T2 minus T1, this particular T will get cancelled out with this. So this is the value which I am going to get. P is not a pressure, P is a constant term. Fine. So I hope you got this particular thing. It was nothing but integration question, but you can expect when he gives you not Cp Cv as constant term, he gives you Cp Cv as function of temperature. So how you have to solve that? Okay, let's read next question now. Heat capacity of the system at constant volume Cv is given as Zt square. Z is also a constant term. Now a system which is originally at 250 Kelvin and a thermal reservoir is maintained at 125 Kelvin. This thermal reservoir is nothing but it may be ambience. You need to find out the entropy change of the system, how the entropy changes for the system. So can you tell me if your system is at 250 Kelvin and it is kept in the surrounding 125 Kelvin, what will be the final temperature of the system? Final temperature of the system will be 250 Kelvin to 125 Kelvin. So final temperature will decrease. Okay, now see this expression. This delta S for the system is Cv log of T2 by T1, but Cv is this particular value. So integration ke baad this will remain like this, and temperature will be 250 initial temperature, final will be 125. So obviously negative will come because entropy will decrease as the temperature is decreasing. So These questions I have given you in which Cp, Cv terms are functions of temperature. Let me tell you, GATE का ना एक typical type के questions are asked in GATE, in which he is going to check your engineering aptitude. You know, engineering aptitude simply means can you integrate, can you optimize the things, differentiate, can you use integration as a tool of basically summation. ट्रिग्नोमेट्री के कंसेप्ट्स आपको पता है कि नहीं. सो वो इंजीनियरिंग एप्टीट्यूड है. एंड प्लस कैलकुलेशन. बहुत डिफिकल्ट, बहुत लेंथी क्वेश्चन नहीं देगा, लेकिन ऐसे क्वेश्चन देगा इन विच यू आर टू यूज द इंजीनियरिंग techniques or engineering aptitude, and chance of mistakes, calculation mistakes are more. That is what you have to do. So let's read next question now. Let's see this question. Air is compressed in a container such that its temperature as well as pressure is doubled. So there is a container in which air is compressed. You have to tell what is the increase in entropy. Don't you know the formulas of now S2 minus S1? Temperature and pressure. So I want to write a formula in terms of temperature and pressure, and I gave you formula in terms of temperature and pressure as S2 minus S1 is mCp log of T2 by T1, mCp log of T2 by T1 minus mR log of P2 by P1. अभी क्या बोलता है वो कि T2 is equal to 2 times T1 and P2 is equal to 2 times P1. So ये क्या गया, T2 by T1 will be equal to 2 and P2 by P1 is also equal to 2. Both are doubled. तो mCp log of 2 minus mR log of 2. तो मैं इसमें ये भी बोल सकता हूँ this is mCp minus R log of 2 if I'm not wrong, log of 2 if I get it, and Cp minus R is nothing but Cv, mCv log of 2. So if you keep on simplifying it, and because he's asked you question I think per kg, you have to calculate up to 2 decimal, you have to find out per kg mein, so m is to be taken as 1. So this is Cv log of 2 and solve at the end. So keep simplifying till the end and just calculate the answer at the end step only. Cv log of 2. Fine. Okay, let us go for next question now. There's a air जिसके लिए आपको Cp Cv is given. Now if pressure becomes double and volume becomes half, then what is the entropy change? Now this formula mein I am going to use the third equation of entropy change which I gave you, S2 minus S1. I gave you 3 equations. What is the third equation now? Third equation is mCp log of P2 by P1 plus mCv log of V2 P2 by P1. P2 by P1. This is V2 by V1. This formula mCp log of V2 by V1 plus mCv log of P2 by P1. अभी क्या बोलता है? Pressure becomes double and volume becomes half. Pressure becomes double. This is 2. Volume becomes half. This is 1 by 2. So this is mCp log of 1 by 2 plus mCv log of 2. I can write it as mCv log of 2 minus mCp log of 2. You know, this is minus mCp log of 2. Log of 2 again you take common, m common, log of 2 common, Cv minus Cp. You know what is Cv minus Cv? That is equal to minus R, minus mR log of 2. So m, I think m is given to us. No, m is not given to us. Per kg में निकालना है. R log of 2. R can be calculated from difference of these two. mR log of 2. Similar question, you know, that you can find it out. And the answer will be in negative. Okay. So let me go next. Read this question. Air is contained in a room at particular temperature 27 degrees centigrade and the room is insulated. If electric heater is switched on for 10 seconds, you know, there is a voltage supply 100 volt, current is 10 ampere and for 10 seconds you supply electric energy. So electric work is IV into I into T. You have to find out the entropy change of the room if Cp and Cv are given to us. This is how we have to use. Now see this particular question. There is a room which is adiabatic room And you know, whenever we supply the electric energy, there is a electric work which I do, and that electric work is I square RT or V into I into T. So V is given to us 100 volt, I is 10 ampere, and T is 10 seconds. So from there we get this much of work is done, and there's a negative work, right? So first law में जब मैं लगाऊंगा तो ये negative work होगा, because adiabatic room है, ये 0 होगा तो delta U बढ़ जाएगा, delta U will be plus dW, and delta U is always CV T2 minus T1, right? So because we know this delta U, you know what is CV, you know T1 also. From there I can calculate T2, the value of T2, right? T2 is equal to this. And if I know T2 and I know this V1 V2 is the same, this is 0, so T1 is known to me, T2 is known to me, CV is known to me. From there I can calculate what is S2 minus S1. So this was the concept which was based upon electric work. So electric energy is nothing but example of work done on the system, which is negative. And the electric heater, if he asks you in the interview, electric heater कौन सी energy है, आप बोलोगे सर electric work है. This increases eventually the internal energy and hence the room temperature. Okay, let's go for this question now. Free expansion is an irreversible process. We know the free expansion is a constant internal energy process. You have to calculate the irreversibility associated with free expansion. He can even ask you calculate the entropy change associated with free expansion. और उसने आपको क्या दे रखा है, उसने आपको वॉल्यूम, फ्री एक्सपेंशन में वॉल्यूम तो बढ़ेगा, V1 से V2 हो जाएगा. सो V1 is 1 meter cube, V2 is 2 meter cube, and R is given to us for air, temperature is given to us, and आपको निकालना है इसका irreversibility कितना होगा. You know, irreversibility, as I told you, is nothing but ambient temperature into delta S of universe. This can also be written as ds generation. This can also be written as T naught S of system plus delta S of surrounding, because universe is nothing but system plus surrounding. But free expansion is such a fast process. Free expansion is such a fast process. Okay, there is no, it can be assumed to be adiabatic, and if it is adiabatic, then ds surrounding is 0, and hence irreversibility for this particular your free expansion process is T naught into delta S of system. Now how to calculate delta S of system? Let's take the help of first law. This is delta U plus PdV, you know, and this dq is TdS. Now in the free expansion delta U is 0. So what is ds? ds is P over T into dV. But for ideal gas, can I write this P over T as R over V? PV is equal to MRT. So I can write P over T as R over V. So S2 minus S1 becomes R log of V2 by V1. Now V1 is given as 1, V2 is given as 2. So I can calculate V2 by V1 as 2. And R value also is known to me. So I can calculate what is the entropy change of the system. And if I get entropy change of the system, if I multiply that with T naught, but that is to be written in Kelvin, that is 300 Kelvin, I get what is the free expansion में entropy change. This is what the concept is. So as I told you, the most important thing is whether you get the right answer or not. That is the most important part of it. You know, similar to free expansion, there is a concept of throttling. As I told you, whatever you do in free expansion का example balloon rupture, right? Tire puncture, that is free expansion, fast process. Throttling is not a fast, I will say, but it is constricted flow. Constricted flow again is assumed to be adiabatic. Later on sometime I will explain you adiabatic कितने तरीके से आप कोई process को adiabatic बना सकते हो. One of the ways to make it fast. Another can be constricted, you know, restricted path कि heat को flow करने के लिए space ना मिले. So throttling is irreversible process, as we know. So entropy will be generated in that. Throttling and free expansion say he can ask you to calculate entropy change, he can ask you to calculate entropy generated, and he can ask you to calculate irreversibility. तीनों question बनते हैं. So in this particular case, he is given you that throttling is expansion process again 10 bar से 1 bar. You know, P1 is given as 10 bar, P2 is given as 1 bar. And ambient temperature T naught, P naught is also given to us. We have to find out what is the irreversibility. That is what we have to find out. Now let us see how we have to find out. So as we know, in kind of throttling process में DH is equal to 0. So see this particular thing now. DH is equal to 0, And if dH is equal to 0, TdS is equal to minus VdP. So S2 minus S1 will be minus R over P into dP. So V over T ko I can write as R over P. So the formula becomes R log of P2 by P1 या P1 by P2. Negative sign को मैंने positive कर दिया. P1 is 10, P2 is 1. Delta S of system, you know, delta S generated for irreversible process will be positive. So both in free expansion and throttling, there is nothing, there's a delta S of surrounding is 0 because the process is assumed to be adiabatic. So delta S surrounding 0 hai, so delta S system will be positive because DS generation is positive in irreversible. So you are going to get delta S system as positive. T naught, if you multiply, this is the value you are going to get it. Let's see the last question now. There is a heat source. Now the last question is about the thermal reservoir. There is a heat source which is at 600 Kelvin and sink at 400 Kelvin, and ambient temperature T naught is given to us. If 500 kilojoule of heat energy flows from source to sink, calculate the irreversibility. Right? So let's see this through a diagram. Source is at 600 Kelvin, sink is at 400 Kelvin, and Q flows from source to sink. So entire heat which flows from source, it goes to sink. So there is no heat going out of this entire system. If source and sink ko make system maan loon, that system will be adiabatic system. So no heat goes out. So delta S of this, because heat goes out of it, I told you how to calculate delta S for thermal reservoirs, Q over T. So Q over T kitna iska 600 Kelvin, and this T is 400 Kelvin. Entropy of this reservoir will decrease, and sink, you know, that will increase. Q by 400 minus Q by 600. अगर इन दोनों को मैं जोड़ दूं, this is the system, this is the surrounding, so that will become universe. And if I add these two, this is the delta S of universe. And what is irreversibility? T naught into delta S universe. So if you put the values Q at the end, if you see, you put the values at the end so that your calculation mistake chance are less. That is how you have to do. So this video of 10 questions, we have done how to calculate entropy change for the ideal gases. 3 formulas I gave you. And if polytropic index is given, how to find out? Cn, if it is given, calculated in terms of Cv. And for throttling process, for free expansion, for reservoirs, how to calculate it? Entropy change. And related to entropy change, there is a concept of entropy generation or entropy change of universe, and hence irreversibility. So that is what we have seen in these 10 questions. They are very, very relevant questions. Keep using these concepts, and certainly the question comes from entropy change concept. Fine. Thank you.